Hello, my name is Tiago Marques and I'm here to provide a brief lecture on analysis hints. So things that you should do in a distance sampling analysis to help maximize the likelihood of having a good analysis and some reliable results. The material presented is taken largely from section 2.5 in the Introduction to Distance Sampling 2001 book, and there's also advice coming from the Len Thomas et al. Journal of Applied Ecology 2010 paper where the software is described. What are these analysis hints? So what can we do to improve once the data has been collected? Well, first thing to know is that this is not a cookbook and you should not simply use the program defaults in distance, because otherwise you'll be no better than this little friend here. And in fact, model selection is as much of a science as of an art, and therefore the thing that you might need to be able to analyze a data set reliably is to analyze many data sets to begin with, and to start having a feeling and a sensibility for what makes a difference and what makes not, and what are the important aspects of the analysis and which are the ones that you do not need to care so much about. Anyway, starting with the exploratory data analysis, which is always very important, the goal is to understand the patterns in the distance data, in the survey data in fact, and make preliminary decisions about the analysis that you might want to carry forward. It's actually never too early to start looking at the data, because then you can rectify problems. And so it's not unheard of situations where people were actually plotting the data while collecting the data on site, and then they were actually changing field protocols or changing the way they were doing the surveys to account for problems that were starting to show up in the data. So it's very important that you review your data as you're collecting it. To look at the data, if you're having exact data, looking at histograms with lots of cut points and QQ plots of the data might be helpful. And these might be helpful, for example, to identify problems with measurement error or animal movement or heaping, which you could try to correct still while making the data collection. You should then carry out preliminary analysis with a simple model. And if you just run the distance defaults, this is a good way of doing it. So you'll have a half normal with no adjustments. And then you look at your histograms to assess if there's any clear evidence of assumption violation. Also, this will give you an idea to see whether the data actually runs in distance or not. And if not, you might have to go to square one, which is introducing the data into distance, which we're not covering in this lecture. Then you'll have to make some preliminary decisions about truncation and whether you should or not group your exact data into bins, for example. And so, again, you'll be looking at plots of the data to make some decisions. For the case with clustered populations, you're going to try to look for evidence of size bias, so to see whether detectability depends on cluster size, as that might determine which kind of analysis you implement afterwards. On a second stage, you can think of choices at the model selection phase. So after you've decided whether to analyze the data as grouped or ungrouped, and in practice, if you have exact distances, simulations have shown that if you group these into more than 6 or 7 classes, you will get pretty much the same results. You will have to select an appropriate truncation distance, and the way to do so is essentially you want to truncate the tail such that you're not overfitting randomness in the tail and you're capturing the overall pattern in detectability as a function of distance. You want to be careful while choosing your cut point if you're using group data. For example, if you have heap data, you want to put your bins such that the endpoints of the intervals are far away from the peaks of the heaped values, so that way you maximize the chance that the values are actually placed in the right bin. Then you might want to select and start fitting a small number of key and adjustment combinations just to see what might be the best fit to your data. You're going to want to check all the histograms, goodness of fit measures, look at AIC for relative goodness of fit, and then look at the summary tables to choose a model. This is, of course, an iterative process. You might want to go back to the drawing table and assess whether you need more exploratory data analysis to be conducted. In the worst case scenario, you might actually conclude that the data that you have are simply unanalyzable and that you need to collect new data. Hopefully you're not there and there's some way of analyzing the data that it's reliable. You want to continue looking for evidence of size bias if the population is in clusters. Quite often, larger clusters are naturally easier to detect. And then you want to account for that either using a size bias regression or using cluster size as a covariate in the detection function. Finally, when you're moving to analysis and inference using the models that you selected, you can actually select the best model and then make your inferences conditional on that model, or perhaps consider the option of model averaging, which is when you have different models that will, even though they have similar goodness of fit, they lead to different results. Then you might want to select a procedure that, for example, by resampling, each time you have a new sample, it refits the model, and so it allows the incorporation of model uncertainty into the final results. Finally, you want to extract summary statistics and histograms or other graphical representations to report your analysis, say in a paper or in a report. And this is it. It was not a long lecture, but I hope it was useful when you are trying to analyze your own distance sampling data. See you later.